folks, welcome. So thanks a lot for showing up for our webinar. My name is Rafael. I'm the product manager for network things at DigitalOcean. And today we're going to talk about VPC. So let's get this started. So thanks a lot for showing up. This webinar will be recorded, so you don't need to worry. You're going to get an email with the link for it if you need. Don't worry about that. We'll probably also upload it in other places. So you have the link for the video if you missed the part of it or something like that. Don't worry, you'll get the video. Let's get this started. So we'll start with a quick intro and agenda. So and then we can talk about the actual meat of the conversation. So my name is Rafael. I'm the product manager for networking products at DigitalOcean. I joined the company quite some time ago, back in 2016, been with the company for 4.5 years almost. And so it's quite some time. And I've been working with cloud products and cloud companies since 2009, when we didn't even know what the cloud really was. So that was, we were figuring out what to talk about and what a cloud was back then. And I've been coding professionally since '95, so I've been around the block for a while. So yeah, that's a little bit about me, but that's not the main thing today. So what we're going to talk about today is about VPCs, right? Virtual private clouds. That's the main conversation we're going to have. I'm going to go over what is a VPC, very high level. We're going to show you how to set up a VPC. We're going to talk about some use cases for VPC. After that, I'm going to do 2 quick demos. They're not super in-depth demos, but they will show you what deployment using VPCs and other network products would look like. And then I'm going to do a demo of the Internet Gateway, which is one specific part of VPC, but it's a very simple one, just so you know what we're talking about. Then we're going to talk about the limitations and implications on bandwidth billing. And at the end, we're going to show you a few links for resources and open for questions. So if you have any questions, please do put your questions on the question box on the interface. At the end, we are going to have those questions answered for you. I'm not going to stop this during the presentation because we want to do the questions at the end. But if you have a question, put them on the questions box. And at the end, we're going to have a conversation. Cool. Let's get this started. So what is a VPC anyway, right? So a VPC is the acronym is a virtual private cloud. But for us, for DigitalOcean, that is an evolution of our private networks. The private networks was one of the first features we launched at DigitalOcean back in 2013. And what it provides you at the time was just a private IP that you can use to talk with other droplets on the same region, right? That was private networks. But there was a lot of limitations with that architecture. We wanted to do more things, better things with that. And that required a lot of work over the years. So VPC, what does VPC today give you, right? They provide you with a fully isolated private network that you can use to connect your droplets, right? So this way you can, if you have 10 droplets, for example, on a region, you can talk, you can make them talk using a private IP without having to go through the public internet, without counting against your bandwidth billing, etc., in a very isolated way. Nobody but your account can see that traffic. It's fully isolated. And the cool thing about VPC, the latest release we made, is that in the past, private networks was very like, you don't have any control, we give you something, but you cannot touch it. And now the idea is that we are going to give you some control. Now you can, for example, create multiple VPCs on each region, right? So you can, in the past, you had one and that's it. You could not control the IP range, etc. But now you can create multiple VPCs in every region. And you can also use an IP address that you want, right? So we are going to give you the option to just use an auto-generate IP range. You don't need to think about that. By default, those networks will be a /20, which can handle about 4,000 droplets inside them, which is plenty for most people. But you can change the size if you want, from /24 up to /16, very big network. it's up to you. You have the choice to use that, the default or something else. And we accept most RFC 1918, which is the RFC that talks about what are the private IPs that are valid, right? So there are a few exceptions on the documentation, but they are for internal services, and that's it. It's very flexible. You can create any kind of private network you want with any kind of IP you want. So that's the cool thing about the new VPC, right? So we removed a bunch of the limitations we had with private networks. We revamped the interface. We are giving you more control, and we hope that you do good use of that. So what I'm going to do here is I'm going to go through a very quick how to set up a VPC. Okay, so it will be a demo. I'll do a live demo. Let's hope that the demo gods help me, right? I hope that they are not going to shut down the presentation. I have some links there for the documentation of the product. There you can see a bunch of screenshots, explanations, but here I'm going to do it live so you can see how it looks like. Okay, so here I have my dashboard, right? So in this specific case, I already prepped some things here, but what I'm going to do is I'm going to just create a new project. I'll call it webinar demo, right? So just like have one here, so I can isolate what we're doing here in a separate screen with no other resources involved. But this is not necessary, right? So by default, you already have a project. You can have several projects. It depends on how you're using our products, right? But creating a new project is not necessary. It's optional. I'm doing here just for cleanliness. So I have inside the manager section here, I have the network tab. The network tab, it is a shared resource across all your projects. Most of the network resources are shared across projects. And VPC is not an exception. So if we go inside here, networking VPC, we are going to see a list of all the VPCs that I have on this account, right? Because I have a bunch of droplets, I already had a bunch of droplets in the past. I have lots of other VPCs that were created on all the regions where I ever created a droplet. So that's why I have them in New York, San Francisco, Toronto, right? So I have a bunch of VPCs here. You might not have them. If you just use one region, you might have just one network here. It's important to know that because this is an evolution of the private networks, we converted the old private networks into default VPCs, right? So if you're already using private networks, they are still operating, no changes at all. You didn't see any blips on your network. We're just changing them into a VPC, and it's a default VPC, right? This is an important thing. Here I'm going to create a new one just so you see what's the process look like. Click there, create VPC. The first thing I need to do is I need to choose a region. So here I'm going to do it in NYC2. Why not? Right. I choose a region that I want to use where I'm going to deploy my droplets. In this case, I'm just picking a random region. And the next step is to choose a private IP range that you want to use. By default, we're going to generate one for you. You don't need to think about it. It will be a /20 by default, plenty of space for most people. But if you want to configure your own IP range, all you need to do is click here, configure my IP range, and then you need to type an IP range that works with. So perhaps 10.22.00/10. That will be a possible IP range. But in here we also allow you to change the size that you want. Sorry for the autocomplete there. That's my password manager. You can have a bunch of different options. If you type an invalid range, we're going to show you a suggestion. We're going to tell you if that works or not. But in this case, I'm not going to do this. I'm just going to get a generated IP range for me. Much easier. Don't need to think about it. /20 works for everybody. Here I am going to put a name for it. I'll create it as webinar demo VPC. That's the name of the VPC. That's how I'm going to see it on other screens. You put whatever works for you. I'm going to talk about use cases later, and that might guide you on how you should call your VPCs. And then here, an optional description. So you don't need to fill that if you don't want to. I'll create the VPC. Boom, that's it. So it created here in NYC2 webinar demo VPC. If I click on it, at the first time you click here, we're going to give you some guidelines for documentation, where you can find things, how you can add resources, configure the gateway, etc. If you want, I'm going to talk more about in details about that. So I'm going to remove this notice here, and I'll show you what a VPC look like. So the information we provided, the description and the name are here. Here you can see the range, the IP range that is going to use, in this case 10.100/20. It repeated here, it shows you how many available IP addresses you have. And there are a few IP addresses. If you were calculating it /20, you see that there are missing a few because we reserve a few IP addresses on every network, about 6 if I'm not wrong. And I don't have any resources on this VPC because I just created that. So when you create a VPC, it starts empty, right? So you're just creating a network in a specific IP range. And it will be empty until you add resources to it, right? So if I want to add a resource to this specific VPC, all I need to do is, let's say I'll create a new droplet. I'll click here, new droplet. It will send me to the droplet creation page. The droplet creation page is just like you're used to, no changes here. I'm going to use all the defaults here on the top. It already chooses the place where you were. In this case, I'm in NYC2. In here, I'm going to choose webinar demo VPC, right? If I open here, I can see all the VPCs I have on that region, right? And that's important because VPCs are restricted per region. I saw a question earlier before the webinar started, and that's important. The VPCs are restricted to a specific region, in this case, NYC2. If I change it for example, San Francisco 2, here I'll have a different set of VPCs. In this case, I just have no VPC or the SFO2 default VPC. If I'm trying to create this in a region I never did anything, you also see a default region name network there. Why is that? Because we don't want you to have to be forced to create a VPC before you start creating your droplets. If you just want to create your droplets and get it started, you don't need to worry. You don't need to create a VPC. That default VPC will be there. You just need to go create your droplet, choose a default VPC, we'll do the job for you. Don't worry about that. In this case, I'm going to go back to New York C2, choose the webinar demo VPC that we just created. It shows you how many available IPs you have. The more droplets or resources you have inside the VPC, the less IPs you have available. I'm just going to select all my SSH keys. I can select the other standard droplet information and configuration. I'm not going to configure anything. I'm just going to create it. So in here, it's provisioning the droplet inside this VPC. In a few seconds, it will be done, and then we can take a look at how it looks like inside a droplet. And remember, if you have questions, please add them to the questions box, and we're going to answer them at the end. And if you just arrived, we're going to record this. You have a recording of the webinar. Don't worry about that. Cool. So it just provisioned the droplet. It's already there. I could use it if I wanted. In here, I have some information about, for example, what's the public IP, and the private IP is the IP inside the VPC. Remember that this VPC was a 10.100/20. So here I have this IP, 10.100.02, right? That happens to be the first IP on this VPC. And I can go back to the VPC by clicking here. If I click on the VPC name, now I see that I have one resource inside it. If I click on resources, I'll see a list of them. So if I have 10 resources, for example, I would see a bunch of them here. I have information about the private IP, public IP, and if I click here, I'll go back to the droplet, right? So just a very simple navigation process for the VPC in the droplet page. And that's how you create a VPC and you create a resource inside a VPC. That would be similar for any other things. If you're creating a database or if you're creating a Kubernetes cluster, anything like that, you always have the same options. You choose a region. The region will restrict which VPCs you can use. You always have a default VPC if you want. If you don't, that's okay. But the only catch is if you don't want to use the default VPC, you should create a VPC ahead of time. The reason for that is simple. VPCs are networks. It's like you're laying down networks in a data center. Of course, the software. You don't need to pull the cables and do all the complicated things on a network, but you should think about how you want to organize your network. It's not something that you should do on a whim. If you're creating custom VPCs, you should think a little bit about how you're doing it. If you have lots of resources, multiple droplets, hundreds, tens, or even 10 droplets, right? So you should think about how you want to configure this. So you need to stop and think a little bit about how you're going to use your VPCs. That's why If you want to create a custom VPC, you need to create a VPC first and then add the resources. For the moment, we don't allow you to move resources from between VPCs, so you need to think a little bit ahead of time. In the future, we might make this a little bit more flexible, but for now, think about your VPCs, how you want to organize them, and then create a resource inside it. Cool. Let's go back to the presentation, and then we will continue. Okay, so let's talk about use cases for VPCs, right? So far, I showed you, I spoke a little bit about what's a VPC, what it does. I showed you how to create one, how to create a resource. And we are going to talk about now the use cases for people having multiple VPCs, because a lot of people, they already had private networks. It was enough, but we have a lot of customers that want more, right? For many reasons. And I'm going to talk about some of those reasons right now. So one of the most common reasons of why you would want multiple VPCs is for environment isolation. So a very common scenario is you have different development environments inside your company. So you might have, for example, a development environment, a staging environment, and production environment, assuming that you only have one system, right? For this specific example. If you have those different environments, you might want to make sure that whenever you're deploying something and doing things on that environment, it cannot by accident just get into another environment and do things by accident, right? One classical case is you're deploying a database schema change. For example, you're dropping a table or something like that. And instead of doing that inside development, you do it in production and you lose all your production data. That's a very unhappy situation. It happens. Most people will have to deal with that once they have enough years on their belt. But that's not a very fun situation. It's a very bad day. So you don't want that. So a good thing to do is to split your environments into development, staging, production, whatever works for your case. But the idea here is you split the environments into separate networks. That will constrain what you can do inside the private networks. You need to be using the private IPs to make sure that this is going to work. If you start using the public IPs, you can have the same issue. So think about that, especially when you're dealing with databases and resources that should not be public, right? A database is a classical case. Your database should not necessarily be accessible through a public IP. It doesn't make sense. So you should restrict it to to use private IPs. And whenever you're making script or a deployment, you should be using the private IPs to do that. So think about that. That's a very traditional case. Here we have a diagram. These diagrams are from our documentation. So the documentation we're going to give you at the end, the links, will have all this information again there in more detail. But that's number one. That's a very common use case for multiple VPCs. Another very common use case that we get a lot is tenant isolation. So let's say that you are a web agency. Web agencies are a very common situation like that. You work on sites for other folks. You offer your services for other people. You build sites for other people, like web agencies. And for every customer, what you could do is you could have a separate bunch of resources in a separate network for each one of them. This will make also avoid issues. For example, you're, again, going back to the database schema change, right? You are going to deploy a schema change for tenant 1, but instead you did it for tenant 2. But because you missed the IPs or using public IPs, you're going to do the wrong thing. So you should avoid doing that. You could avoid that by doing what? By creating separate VPCs. Everyone will be inside a separate network. You cannot talk between those networks. And then you isolate the blast radius of an error like that, right? So that's a very common situation why you should do tenant isolation. Other cases is like, for example, you're going to give access to some of those machines to someone for your tenant, for example, and but if they are restricted to that specific IP, they can do less damage about messing up with someone else's resources that is inside your project or something like that. So keep in mind, that's another very common use case. You can create a VPC now for every one of your tenants if you want. That's a very common use case. So I gave you these two high-level use cases. Now I'm going to show you a small demo that I crafted here is mostly just resources I set up. So I'll show you how you can use these items together, right? So let's do it. Oops. Let's do this. So here I have a few items. So I created here what I'm calling a 2 tenants, right? I have biotenant and mech tenant. I'll show you why they have these names. So inside biotenant, biotenant is one of my tenants, one of my customers, right? Here I have a very traditional but very simple, very simplified application. So you just can see the high level how things connected. I'm using most of the items we're talking here and even more. So inside biotenant, I have a load balancer. This load balancer is fronting 2 web servers that I have here, bio server 1, bio web server 2. I have a spaces bucket that I'm where I stashed some images that I'm going to use on the web servers. In this specific case, I'm going to also show you how I use the VPCs here, and also how I'll use firewalls. Just to give an idea, what does this application does? It's a very simple one. So if I go to this specific URL and I reload it, I'll see that it's changing between 2 biological semi images. I'll show you the mecha one later. So I have these 2 semi images here. For those who don't know, semi is our mascot. We have lots of versions of semi. We love semi very much. A lot of our customers have a collection of stickers with semi. So I have my collection as well. So this application is a very simple one. The web servers, they are showing this web page. Behind the load balancer is doing this using a round robin algorithm. That's why whenever I reload the page, I get something different, because each server is showing me a different image. This is for demo's purpose, of course. In this specific case, I'm using a load balancer that is using a tag. So I'm saying create a load balancer, and I'm saying do the load balancing on port on the SSL port using for any server that I have here called web server, right? That has a tag web server. And these 2 droplets that I created here, they happen to have this tag web server. If I added a 3rd droplet here, the bio web server 3 with a different image and configure it kind of similarly and added tag web server, it would also be added to this load balancer. That's how you use load balancer with tags, right? And this is a very simple application. Those images, these images here. Oops, what happened here? Apparently, oh, here we go. So these images here, they are coming straight from Spaces, which is our object storage product, right? So they are coming straight from Spaces. They are not hosted inside the web servers. And in this setup is an example of how I would isolate one tenant that has this application which show images. In this specific case, I'm not only creating a dedicated VPC for them, I'm creating a dedicated project. So projects in VPCs, they are not the same thing. A project is a grouping of resources. In this case, load balancers, droplets, spaces, buckets, right? And it can have other things like Kubernetes clusters, database service, whatever, other resources here. And VPCs are not necessarily related to projects. They are what we could call orthogonal, right? So you could have a project that 2 projects using the same VPC under the covers, or if you want, you can create separate projects and create a VPC for each one, and then you use the right network, the right VPC network inside each one, which is what I did in this case. So if I go to manage here and go to networking and VPCs, what I'll see here is that in this specific case, I'm deploying this in Toronto, right? So I created 2 networks here for Toronto. One is called biotenant VPC, and another one is called mech tenant VPC. They are separate networks. They have different IP addresses, and they have different resources. So if I click on biotenant VPC here, I will see that inside resources, I have those 2 web servers I mentioned and the load balancer, right? The load balancer, if you're trying to use private networks to do the load balancing, you should also create a load balancer with that inside that VPC, right? So all those 3 resources are inside this VPC. And this is an example how you would isolate a tenant inside the VPC. And in this specific case, I created a separate project for them. I suggest that you do something like that if you're trying to split tenants, because it helps to organize things in a very neat way. So you separate the resources using the projects, and you separate the traffic of the data using VPC. This is the example here. So for example, just to show you some interesting things. So in this specific case, I'm going to show you also how a firewall would play on this, right? So I have here web servers 1 and 2. I'm going to copy the public IP for BioServer 1, and I'm going to open a new tab, and I'm going to try to access this. This server cannot be accessed because I already blocked this server on a firewall. So the firewall that I configured doesn't allow me to access directly. I only allowed the firewall to access the droplet through the load balancers, and that's why when I access the load balancer, I can do this, right? So here I am accessing this bio.setup for me. This is not pointing to any of the web servers; it's pointing to the load balancer. And when I hit it, it's going to route to the right web server based on the round robin algorithm behind the scenes. So this is how you would mix all those items together: the droplets, the load balancer, the VPC, mix everything and have a setup here. Here I'm going to show you the Mac tenant one, right? So that's a different one. That's a much simpler project. I just have a droplet here. If I try to access it here, I can access straight the IP address, or I can I can use this and go straight to it as well. In this case, I'm not even set up the SSL or anything like that. In this other case, I use it Let's Encrypt integration of our load balancer to create an SSL certificate for this one. So I don't need to manage that. As long as it's managed by the load balancer, everything's good. In here, I have the Mac semi set up. If we go back here to its page, we'll see that we have fewer resources, just the droplets and the spaces. There's no load balancer or anything like that. If I go to networking and click on VPC, and I go to the Toronto section here, I can see inside the Mac tenant VPC that I only have one resource, which is that web server that I showed you, right? But the setup is kind of similar, right? So this is how you would split and isolate 2 tenants. I would suggest you use projects so you can split. The projects is not a paid thing. It's just an organization feature that we provide you, so you don't need to worry about paying anything extra. You just pay for the resources that you use. That's it. I separate them using projects, and I separate the network using different VPCs for each one. This way, I can isolate the traffic, and things are a little bit more organized. If I have a lot of customers, this is more important than in this case, because this is just a toy demo application, right? Cool. Let's go back a little bit to the presentation here and talk about other things. Again, if you have questions, please leave them on the box. We're gonna get to them at the end of the presentation. And for anybody who arrived late, we're recording this. You're gonna get a link to the webinar. So let's talk about another thing, which is the internet gateway. So one traditional setup for, depending on how you do things, is that you might want to isolate your resources inside the VPC and not allow them to talk to an external system, right? So this is an example here. So on the left, we have the traditional, you just deploy your droplets. They are inside the VPC. They can talk to each other inside the VPC, but they all have internet connections that are straight to the public, right? So that's a normal setup that we do, that you would do if you just create a bunch of droplets inside the VPC. But some people want to constrain how those droplets can access the web for many reasons. It might be security, auditing reasons, or whatever. There's a bunch of reasons for that. To do that, you would need to create what we're calling here an internet gateway. In our case, an internet gateway is not a new kind of resource. It's just a droplet that's configured to work as an internet gateway. And how does that change the traffic, right? So that forces all your droplets that are inside the VPC to go talk to this net gateway. This internet gateway. The connection will be netted through that specific internet gateway, and then it go out to the public. Let me show you a little bit how that works with some terminal demos here, right? So it's not going to be pretty, but might be useful. So this is one specific case, right? So here, what I did is this: I set up 3 different servers. Let me show you how they look like here on the web. So this is I created a separate project for them, so I could quickly, easily here and see them. And this is the project I'm talking about. So here I have 3 droplets. I have web server 1, I have an internet gateway, and I have not behind gateway web server, so to speak. So in these specific cases, I just want to show you how the connections work, right? I have these three set up here. And what I did is this: the web server 1 is inside the VPC, but it is also I configured the gateway to use the internet gateway droplet as a gateway to the internet. What that means is this: if I go here and here I'm connected through a terminal on all of those. Here I am SSH into the specific web server, and if I try to ping Google, it will work, right? So let's say, okay, I'm pinging Google, awesome, it's working. If I try to ping DigitalOcean.com, it works. If I do like an apt update, it will work. It will get all the updates it needs to do. It's working just like it's a normal application. But if I try to get it, let's find its IP address here. I can get it here. Right, so if I do an IP address, show if 0, that's the public IP. The public interface, this should be the public IP for this specific machine. If I create here another terminal and I just try to ping, here, and I try to ping that specific IP address, it will not allow me to do that because I blocked all the ports on this specific web server. It can only talk to the web through the internet gateway. How you can check if that's true? So here I have this other droplet that's not behind the gateway, and if I do something like curl ipconfig .me, this is a service that tells you what's your IP whenever it works. Sorry, it's not my ipconfig is ifconfig.me, right? So my bad. So if I try to access this service, it tells me what is the IP address. In this case, it's 64.227.57.149. If I go back to my dashboard, I'll see that's the IP I'm using here, 64.227.57.149. That's the public IP of this droplet. So here I can check that yes, that's the IP that this external service is seeing. If I go to the internet gateway and do the same, it will show me the internet gateway IP 64.227.60.264.254. So here we can confirm, yes, that's the IP address of the internet gateway. But if I do the same here on the web server that's behind the internet gateway, you see that it's not replying with the web server public IP because it's going through the gateway. So it's replying with the IP, the public IP of the gateway, in this case 64.227.60.254, which is the same as this one. So this is how the traffic will look like when you have this internet gateway set up. This is not a mandatory usage. You don't need to use the internet gateway if you don't want. That's fine. You don't need to worry about that. But if you do want to put an internet gateway, now you can. In the past, before we released VPC, this was not a possibility. Because of a bunch of historical reasons, we restricted the spoofing of IP address, and you could not have IP address spoofed like to do the masquerading that you need to do for this netting, right? So this is a different conversation. So if here, just so you know, we have a whole guide, the whole tutorial on how what you need to do to set up an internet gateway, right? This is an advanced config. You don't need to worry about that most of the time. But if you do want to have a VPC internet gateway while using VPC, that's how you do it. Now you can. The possibility is here. The documentation is here as usual. Cool. So just quick recap. We talked about what's a VPC, how to create a VPC. I showed you a few use cases. I showed you how I isolated one specific tenant here for, in this case, with the semis, just so you saw an example. That's an example. I showed you the internet gateways using VPCs. So that's a lot of the items. The next point we're going to do here is we're going to talk about the limitations of VPC and how what's our implications for bandwidth billing. After that, we're going to go to questions. So a few items to let you know. So we do not support VPC networks in between different data center regions. A VPC network is isolated to a single region. In this specific case I was showing you, I was using Tor1. Or let's say that I was using NYC2, for example. I cannot have a VPC that spans NYC2 and NYC3. They are isolated. They need to be regional. There is a reason for that. The reason is that when you have an application that spans multiple regions, you need to assume that the connection between those regions cannot be guaranteed, because they are not on the same building. They are not using the same switches. We don't have the same level of redundancy that we have inside a region, right? So you should never trust that whenever you have two separate regions and you have an application running on them, that the connection is seamless and that the connection will never break. If you assume that, you could do an error, which is, for example, deploying the database on region 1 and the application server on region 2. And if you assume that the connection will be there, you can just do that, assume that the connection will be stable, but it might not. So we don't want you to think of that. This is not a good practice. If you are trying to build multi-region applications and you want them to be highly available, etc., you need to think that each region should be independent as much as possible. So that's why our VPCs are not connected between regions. We might make this a little bit more flexible in the future, because we know that some customers know the trade-offs and they want some extra features. We might make it more flexible, but for now you can't. That's number one. Number two is that right now you cannot migrate resources between VPCs networks. So you cannot get a droplet or automatically migrate it to another VPC or load balancer or Kubernetes cluster. You can, with droplets, you can use the snapshotting process, right? So you have a droplet, you snapshot it, and you get the snapshot and deploy it on another region with a different VPC set. That you can do. But it's a very troublesome process, and most people will not like to do this all the time. So it's a little bit restricted. We might make this a little bit more flexible in the future, but that depends on other changes. So for now, you cannot easily migrate between regions. You can droplets, you can with snapshots, but that's it. What else? Another limitation of VPC is that right now we don't support having one droplet, for example, with two interfaces in different VPCs. For some reason that would be good, but we don't support that yet. We are working on routing between networks. This is going to happen in the future. Also, this is an issue, like we cannot route between subnets for the VPCs right now. We are working on figuring out how this will work in the future. Another small limitation is that the VPC ranges cannot overlap. So if you create two VPCs, they cannot have the same IP address. If another customer is using one IP address that you want to use, that's not a problem. If you have different accounts using the same IP range, that's not a problem. But inside one account, you cannot use the same IP range. So that's a small limitation. You should avoid using the same IP address, IP range for multiple VPCs. The next item here is that we do reserve a few addresses for each VPC. For example, we reserve the first address, the 1, right? Whatever your IP range .1, that's reserved for us, and a few others at the end of the range. And we don't support broadcast and things like that, but that's a normal behavior on most cloud networks, because cloud networks are different from physical network. You have some restrictions. Like besides broadcast, it doesn't also support multicast, which is also a very common case for cloud networks in general. the next step before we go to the questions is talking about bandwidth billing, how bandwidth billing plays with VPCs. Our bandwidth billing is pretty simple, right? So if you're transiting anything through a public IP, that traffic is going to count against your bandwidth billing allowance. That's it. And the more droplets that you have, the bigger is your allowance. And our allowance are extremely generous, right? So if you have a small droplet, you already get like 1 terabyte of bandwidth, which is a lot. Like if you can look at the market, our bandwidth billing allowances are by far very generous. It's extremely generous. And even if you go over your allowance, our cost per gig is very low. We're talking about 1 cent per gig, which is the lowest in the market. So you see good prices there. So our bandwidth billing is very generous for that. And the thing is, if you don't want to use your bandwidth billing allowance, what you should do is you should use the private IP, and that's where VPC comes in, right? So any traffic inside of VPC goes over a private interface, a private network interface, so it won't count towards your allowance. That's it. That's simple like that. If you use the public interface, it will count. If you use the private interface, it doesn't. That's it. So if you have a lot of traffic between droplets, for example, a web server talking with a database or an internal service or whatever, if you can use the connections over VPC, that will make all the traffic go on private interface, and that will not count against your bandwidth allowance, which is great. So that's a way for you to save money on bandwidth billing when you're using VPC. We recently launched, along with the VPC launch a few weeks ago, we also launched a new website that is the DigitalOcean Trust Center, right? So this is in the calculator. Sorry, two things. One is Trust Center, the other is the bandwidth calculator. So this bandwidth calculator is a way for you to play with how many resources you have, the size of your droplet, etc., and see how much bandwidth you have, right? And the more droplets you have here. So here it starts with 1 droplet. If I add another one, let's say another small one, it will already increase my allowance by a lot, right? So here you can see how much allowance you have and where it's coming from, etc. So you can do a bunch of calculations. That's one thing. And the other is the Trust Center, which is a page dedicated to security, or the security features of DigitalOcean. So you can take a look at that. But bandwidth billing calculator will help. A lot of people were asking for this over the years. We finally delivered. And we also have the Trust Center that was launched along VPC. Cool. So before we move forward, and while I have a quick sip of water, we are going to go into the questions section. Here are a few links for things that you might want to take a look. So the documentation for VPC, the API documentation for VPC, our community website, our YouTube channel where we upload all the webinars and other videos and events that we do. So these resources are very useful for you if you're using VPC or if you're using anything at DigitalOcean. Take a look at those. Our documentation is top-notch. You will find a lot of good stuff there. And as a special offer here, for those that are new to DigitalOcean, whenever you sign up using that link there, dios.co/VPC, whenever you use this link and you're new to DigitalOcean, you get $100 credit when signing up. So that's a small thing that we're doing there. And let's see, perhaps now we can start to get to the question section.
Awesome. Well, thank you everyone for tuning in. We have received more than 70 questions and have only 15 minutes left. So we'll try to answer as many as we can live. If your question is one that we don't get to answer live, we'll answer it later in a document and share that with you via email, along with the video recording and the resources. So, Rafael, don't droplets inherently separate resources? Not quite understanding the isolation benefit of a VPC.
Yes, so when you have a droplet, you're isolating, for example, what's inside that droplet, right? So let me show my screen here. Let me find it. Okay, for example, in this specific case, here I have, by the way, can you see my screen here? Because I lost my tracking.
Yes, I can see your screen.
Okay, sorry, I lost my tracking here of the place that was showing me what you were seeing. Anyway, so here what we have is this. We have this this tenant, right? This specific tenant, each of one of those droplets, they are separate web server, right? They are a separate virtual machine, which we at DigitalOcean we call droplet. And your resources, if you deploy an Apache web server or a Ruby application, whatever, yes, they are isolated inside the droplets. But the thing is, the important thing is when you're trying to do a networked application. So traditional application, let's say you have a web server running Ruby on Rails, and you have a database. For example, our database service running Postgres. Those would be two resources. They would be in separate. They would be separate resources. One is a droplet, and the other is a managed database service. You need to communicate with them. So when you do that, you should do that over a private network, and that's a VPC, using a VPC, right? So the VPC would be the case. The problem of isolating different tenants using VPC is that you make sure that there is a separate IP address, private IP address for each one of those customers. One thing I didn't show you here is this other terminal here, right? So here I have the web servers that I was showing you, the semi web servers, right? So I have here I have on the left top I have web server 1, on the right I have web server 2. I can ping, for example, this 10.188.16.5, that's the IP address of web server 2. I can ping from one to the other. I can, of course, ping is just a way to show you that I have connectivity between them. And I can do the reverse. I can ping from web server 2 to web server 1, right? So they can talk, right? So here but that communication is going over a private network and isolated. Here I have the other, the mecha semi, the mechanical semi web server, which is in a separate project and a separate VPC. If I try to look at, for example, what's the IP address here on this specific server, it will show me that it's 10.188.32.2. This is not the same network as this one. The one on the top is running on 10.188.16, and this one is running on 10.188.32. So I cannot even see the IP addresses between them. So if I do something here on the Mecha Semi and I try to access by accident the private IP address of web server 1 on the BIOS Semi version, I will not even reach that IP, right? So that's how I'm isolating it through the network. That said, not everybody needs this kind of isolation. Depending, if you have a very simple application, you might not need this kind of isolation. This is going to be useful for people that have multiple tenants that are trying to really isolate their projects because of security or auditing reasons, right? There are a bunch of reasons why you should do this, but that doesn't apply for everybody. Sometimes it's too much stuff and you don't need it. I hope I answered your question.
Great, thank you. Well, VPCs are cool for access separation, but what if we would like to have backup or redundant app or server in different data center, just for the case when the whole data center is not accessible for any reason? How do you configure load balancer or proxy? Any suggested or built-in solutions?
Yeah, so I can talk about that. So we do have customers. It's funny at DigitalOcean because we have customers that have very tiny applications, ones running on a single droplet, up to customers that have thousands of droplets running very big applications distributed across regions. I remember a customer that they have a main region that they use is Amsterdam 2 or 3, if I'm wrong. They use most of their things is in Amsterdam, but they have a backup site in NYC2. Why? Because if Amsterdam goes down for some reason, they can still have access through their stuff on NYC2. But how do you accomplish that? So you need to build your system to be multi-regional and work on this multi-region setup. Usually when you have this kind of very region-based high availability setup, you would do not necessarily with a load balancer, because load balancer would be in a region. The load balancer itself needs to live in a region, right? So if you had a droplet, for example, in MS2, that is your main load balancer, and MS3 goes down, that load balancer goes down as well. So when you have this kind of high, complicated setup between regions, you usually have a DNS load balancing solution, and then you would solve this on DNS. So DNS, which is a much more stable but slower system, at least for high availability, it would see, oh, MS3, I cannot send stuff there. So the secondary is NYC2, send to NYC2. But this is not something that you can do on a pinch. That requires planning, that requires some technical details in finesse. So there's no easy, quick way to do that right now. We don't have a tool for you to do that. It would be great. We are considering perhaps expanding our DNS offerings so we can actually do something like that better and easier in the future. But right now, you will need to think about and think about how you want to do this. You will need to deploy your application to different regions. You will need to have a higher level layer of DNS, for example, that would make the high availability between the zones, or you could use a third party that just do the global load balancing that you might need. There are third parties that do offer a global load balancer because they change the way you do load balancing. But we at DigitalOcean, we don't have a product for that. You might take a look at our marketplace. Inside marketplace, we have a bunch of partners and things. There might be a solution for global load balancing inside our marketplace, and that might solve your situation.
Awesome. What are your recommendations for sizing of the internet gateway droplet, assuming the gateway droplet is built like any other droplet?
Sorry, can you repeat the start of the question?
Yes, sure. What are your recommendations for sizing of the internet gateway droplet?
Okay, yeah, sizing. So sizing depends on your traffic. We don't have guidelines for that because the whole internet gateway setup is new. We don't have hard guidelines for that. I would suggest that you start small and then grow as you see the need in the traffic going. If you create, for example, a small droplet, as long as that droplet is not doing 500 things, it's only used for internet gateway and a few other items. Like, for example, you can use an internet gateway as a bastion, right? A bastion setup is like you cannot log in straight to your boxes, to your end boxes. You need to log into this bastion machine, and from that bastion machine, you log into your application. For example, this is what I'm doing here. In this case, for example, here, this when I was doing the demo for the internet gateway, this specific connection here is not going straight to the web server that's behind the internet gateway. I'm SSHing into the internet gateway, and through the internet gateway, I'm connecting to the backend because I cut all the public connectivity to this specific box, right? So this is the way that you would do a bastion setup, right? So similar. You could do the same for applications. Sizing wise, I would suggest that you start with small box and then grow as needed. If you don't have a lot of traffic, or if your traffic is not fully loaded at once, you might go with a smaller box, and that should work for you. But then again, it depends on your usage.
Thanks. Can you use firewalls to filter traffic in and out of VPCs? And after I've created a VPC, do I have to add a firewall onto a droplet to avoid another droplet on the same switch to listen to the communication?
You can use firewalls inside for VPCs. And the reason for that is because if we go here to networking and go to firewalls, and I'll create here a new firewall just to show you what I'm talking about. So if I create a new firewall, I'll not do much here. What you have here is the sources, right? So in this case, inbound rules and outbound rules. Because sources and destinations are just IP ranges, what you can do is that you could add a 10.100.0.0/16, for example, as a allow rule, as an inbound rule. So in this case, I'm allowing inbound SSH only from this IP address. And then when I apply this firewall to a specific droplet or set of droplets, that all the connections would be filtered by this rule, right? So if I try to SSH into a box that has this firewall applied, it will check, does the source comes from 10.100, whatever, this IP range here? And if the answer is no, it will not be allowed inside the droplet over SSH, and that's it, right? So because every single VPC has an IP range that you can configure, or we can configure for you, but you have a fixed IP range, you can now use that IP range for sources and destinations in traffic when you configure a firewall. So so you can use VPCs here as well. Just use the IP range, and that's it. We're going to add here an option so you can type the name of the VPC. We didn't do yet, but we're going to do that very soon. So you have the option to just type your VPC here, should work. or use the IP ranges that you configure there, and you should have the same regular things. You don't need to use firewalls. We do recommend, of course, that you use firewalls because it's safe. Cloud firewalls helps you to have a single place where you can change the rules and apply to a bunch of folks, to a bunch of droplets. So it's very useful to have firewalls. We do recommend that you do. If you don't use our cloud firewalls, we do recommend that you use IP tables, UFW, whatever works for you in your specific scenario. Just put a firewall somewhere, right? But we recommend cloud firewalls because it's simpler for you to use. But perhaps if you need more fine-grained control or some specific rules that we don't support, then you might use IP tables or something like that. Whatever you do, use a firewall. It's not mandatory, but it's suggested.
Great.
More questions?
What is the price for enabling the load balancer?
So load balancer depends. It's a $10 per month, and that's it. It's pretty simple. The load balancer. Let me show you here. I'll just show how to create a load balancer very quickly. So if you go to load balancer's page and click create load balancer, here you select a region where you want that load balancer to work. For example, San Francisco too. Let me choose Toronto because here I have different networks. And let's say that I want to create a load balancer for our Mac semi, right? So I'll create it. I'll choose a network. I can just use the default, or I can choose one custom net VPC that I created. I can add here the droplets that I want you to load balancer to, but I don't recommend necessarily putting the droplets. I would suggest you use tags, but that's a separate conversation. You set up the forwarding rules. The default rule is when you get a message on port 80 on the load balancer, send to port 80 on the target droplets. You can, of course, configure a bunch of other rules. For example, at HTTPS, you can configure HTTPS. We do have an integration with Let's Encrypt load certificates, and you can upload your custom certificates. There's a bunch of options here. You set up a few advanced settings, click Create Load Balancer, boom, it's working. But the thing is, this will only do the load balancer of the traffic, but you need to make sure that your applications can work with a load balancer properly, and that depends on your application. So it's not complicated, but you need to tweak some stuff depending on what you're using. If you're using Nginx is one thing, Apache is another. Should not be complicated, but you need to tweak your application, and that's it. So load balancers will send the traffic to the proper places, like I showed here with our bio tenant, right? So every time I hit the load balancer, because it's a round robin, it will send me to a different web server. That's why we're seeing different pages here, different semis, and that's it. It costs $10 per month, and that's all. We are working on improvements on load balancer, so expect some news for load balancers in the coming months, but that will take some time.
Awesome. Thank you so much, Rafael. One last question. When can everyone start using VPC?
Everybody can start using VPC right now. We launched it a couple weeks ago. It's already available. VPCs is a free feature. You don't need to pay anything. VPC is a way for you to organize your networks, and we don't charge anything extra. You only pay for the resources that you use, even if they're not on a VPC, right? So just go and create your VPCs, start organizing your applications, your tenants, whatever works for you. Please, please, please do read our documentation. Our documentation is very, very good, has a lot of information. Our community website has a ton of extra information and questions from other users and things like that. So do take a look at our community and our documentation. You have a lot of information there that will help you get started. And we are here to help. I hope that all the conversation over the webinar is going to be useful for you. We're going to get the video link for you. It should be on YouTube as well. So you can go back and see everything I spoke over the last hour in the future without needing to remember everything I said.
All right. Thank you, everyone, for tuning in. Hope to see you again soon, and let us know what more you would like to learn about, and we will address them in future webinars. See you next time.
Thanks a lot, folks. Have a good day. Bye-bye.